Hi everyone, and welcome to Algebra 2 Lesson 1.5a. So we're going to continue at looking at equations of lines, and what we are going to focus on today is basically the equation of a line. All right? Now, even though a straight line that's shown here is technically a function, we can call this a linear relations as well. And the reason is, it's basically in the definition here, right? When points on a graph lie along a straight line, it's called a linear relation, meaning the relationship between all the points forms this line that's shown here. Linear relations can be represented by an equation. For example, the equation of this graph can be written as x plus y equals 8. So now we have something called the standard form of an equation. All right, so equations have a couple of different ways we can write them. And you learned this in Algebra 1. The first one is a standard form, the second one is point-slope form, and the third one is called slope-intercept form. That's the one everyone remembers, the y equals mx plus b, which we'll go into. So linear equations are often written in standard form. So standard form is ax plus by equals c. Okay, where a, b, and c are integers. So those are your coefficients and your constants. And a has to be greater than 1, greater or equal to 1. Okay, so you really can't have, when you think about it, 0.8x plus, let's say, 2y equals 3. Because you see how this a is not greater than 1? So that doesn't work. Greater or equal to 1. And the greatest common factor of a, b, and c is 1. All right, so we're going to write each equation in standard form. Now, what happens is that you got to remember that standard form ax plus by equals c. Notice that a is positive, right? I want you to notice that that is probably the most important thing in standard form, that a is going to be positive. So I'm going to do the odd ones, and we're going to leave the even ones for classwork. Now notice that number 1, that it's negative 5x plus 6y equals 12. Well, if I want to get my a, which is 5, right? Because this is my a, this is my b, and this is my c. I want my a to be positive. So if I go ahead and I make this a 5x, I have to make this a negative 6y and a positive 12. So all I did was change the signs or multiply everything by negative 1. Because if I change the signs of one thing, I have to change the signs of everything. All right, let's go ahead and look at number 3. Notice my x is my a, right? My coefficient of y is my b, and my c is over here. Well, if you look at this, where is c? C is on the right side of the equal sign. Where is my c over here? It's on the left side. So if we move that over to isolate, right, that constant on one side of the equal sign, that'll put this into standard form. So what we could do is we can add 24 to both sides. That gives us 9x plus 6y equals 24. Now, for the most part, we're close to standard form. Okay, and many would argue this is kind of like standard form, right? You have an ax and a by, it's positive, we're all good. But I want to flip back to this other little part of the sentence where it says the greatest common factor of a, b, and c is 1. Basically means, can you simplify? Do they have any factors in common? Well, what goes into 9, what goes into 6, and what goes into 24? The answer is 3 goes into 9, 3 goes into 6, and 3 goes into 24, making this 3x plus 2y equals 8. And notice, now what is the largest factor that goes into all three of these, or the greatest common factor. See how 1 is the only thing that goes into all three? So that's how you know you're in standard form. So you need to go ahead and factor out the greatest common factor between them to get it down to where the greatest common factor now is just 1. All right, let's go ahead and look at number 5. When I look at 5, what do I see? I see that, right, this is my A, and this is my B, and this is my C. What is the problem with A, right? Is 3/4 greater than or equal to 1? The answer is no, right? 3/4 is less than 1. So that is a problem. So the trick is we don't want to have fractions here. And how do we get rid of or clear our fractions? Well, we look at our denominators, and we have a 3 and a 4. So what is the lowest common multiple of 3 and 4? Well, you have 4, 8, 12, 16, and 20. Then you have 3, 6, 9, and 12. See how they all both have 12? That would be your lowest common multiple. So how many times does 4 go into 12? Well, the answer is 3 times. Actually, we're going to go a different way. What I'm going to do actually is just multiply by that least common multiple. I think this will make it easier. So 12 times 3, that's 36 divided by 4. X, 12 times 1, divided by 3. Y, and 12 times 1 there is 12. Now 36 divided by 4, that gets us 9. 12 divided by 3 is a negative 4, and that 12 is left over. So now when we have that, we are now in standard form, because 9, 4, and 12, or 9, negative 4, and 12, the greatest common factor is 1. All right? Excellent. All right, now we move on to slope-intercept form. Slope-intercept form is actually the one you probably remember. That is our y equals mx plus b. Now, technically, it would be a function, right? Because it's a line. So this can also be written as the function of x equals mx plus b, where m is your slope. Remember your slope? Okay, and b is the y-intercept. So let's talk about slope, right? So slope is the constant rate of change between the points. Think rise over run. Remember? So when you get a line, it goes like this. And remember, you had to count up this, right? That's your rise over run. How far does it go up compared to how far does it go over? All right, so there are 4 different types of slopes we're going to consider, right? The first one is called a positive slope. And a positive slope is going to be a line that goes from left to right but goes up. That is our positive slope. Next kind is our negative slope. That'll be a line that goes from right to left but goes down. We have a zero slope. Okay, a zero slope is just a horizontal line. And then we have our undefined slope. Fix that up. There we go, undefined. Our undefined slope is just that vertical line. Okay, so this one is from left to right. We are increasing. This is from left to right. We are decreasing. This is horizontal. And this one is vertical, right? All should be reviews from Algebra 1. So write the equation in slope-intercept form, then graph the line. So what we're going to do is, if we've noticed this, right, this is already in slope-intercept form. Y equals mx plus b. So in order to graph this line, what we have to do is identify what m the slope is, which is 2/5, and the y-intercept, which is positive 7. Now, if you remember how to graph a line, we always start at the y-intercept, which is 7. So I go 1, 2, 3, 4, 5, 6, 7. Now, this slope, this 2/5 means I'm going to go 2 up and 5 to the right. But notice, if I go 2 up and 5 to the right, I wind up somewhere over here off the graph. So it doesn't really help. So we have to learn that we can go backwards. So instead of going 2 up and 5 to the right, I'm going to go 2 down and 5 to the left, because that would be the opposite. So if I go ahead, I'm going to go 2 down, and I will go 5 left, which is right there. Then if I want to go ahead, I will graph my line. So lines, if you recall, should look like this. And let me adjust it a little bit. And there is my line. Because I went 2 and 5. If I would have went 2 and 5 again, it would have been somewhere over here. And you see how it would kind of meet? So it works out nice. All right, now, number 9. This is not in slope-intercept form. Slope-intercept form is your y equals mx plus b. Y equals mx plus b. And notice that y basically is by itself. That's what you're looking for, a positive y by itself. So what I want to do is I want to go ahead and get everything that is not y onto this side of the equation. In order to do that, what I'm going to do is I'm going to subtract x from both sides. So that would cancel these out and leave me with a 3y equals a negative x minus 15. We're looking closer, but notice that y is by itself, and this y has a 3 in front of it. So I'm going to divide by 3, which means I'm going to divide by 3 here and divide by 3 there. These 3's cancel out, which just leaves me a y. There is that invisible 1 in front of that x, so that's negative 1/3 x, and negative 15 divided by 3 is a negative 5. So now I am in slope-intercept form, where my slope is negative 1/3, and my b, which is my y-intercept, is negative 5. So that means I'm going to start at negative 5 on the y, which is 1, 2, 3, 4, 5. So right there. And my slope being negative 1/3 means go down 1 and over 3. Down 1 and over 3. And then I can go ahead and I can graph my line. I don't want to move my graph. I want to move my line. There we go. And now my line is graphed. So vertical and horizontal lines. We've kind of talked about this already in the last, I think it was 1.4a, I think, where we dealt with horizontal and vertical lines. We talked about domain and range. So this is what it boils down to. A horizontal line and a vertical line. So if you remember, vertical lines, this slope, that is undefined. Now, why is it undefined? Well, remember that slope is defined as rise over run. So rise is how much does it go up and down, and run is how far does it go left and right. See this rise? So let's say that I pick a point right there. Can you tell me how far this goes up before it goes to the right? Well, it's going up forever. So technically, right? My rise would be like infinity. But that's not what's important here, right? So my rise would be infinity. Or it could be, right, negative infinity, technically. So up here is infinity, down here is negative infinity, right? Going up forever or down forever. The more important thing is the run. What is the run? Does it go left or right at all? No, it just goes up or down. So that run is 0. And what happens when 0 is in the bottom of a fraction, right? In the denominator of a fraction? That is always undefined. And that's why a vertical slope like this is undefined. All right, so now horizontal lines and vertical lines, their equation is defined by where is it located on the graph on the x or the y axis. So this is our x-axis, and you see where it goes through? You see how that is x equals -3? Because -1, 2, and 3. So this equation of this line is x equals -3. All right, number 12, you can figure out what that is in a minute. Obviously, it's not x equals something. Notice it's going this way, so it's going to be the other letter equals some number. All right, parallel versus perpendicular. Now, parallel lines, the slopes of parallel lines are always equal, right? Or you could say they're the same, right? Slopes of parallel lines are the same. When you think about it, parallel means they're never touching. So if it goes up 1 and over 2, this one's going to have to go up 1 and over 2. Otherwise, eventually they are going to touch. Now, perpendicular lines, those are the negative reciprocals. Now, what is a negative reciprocal? Well, that just means the exact opposite. So when you think about it, if this line is, let's say, is going up 1 and over 2, in order to be the opposite and make this 90-degree angle, this line has to be going down 1 and over 2. Down 1 and over 2. Right, so we could say the slope of, let's call this line A, and the slope of line B. So the slope of A is 1 over 2. The slope of B, okay, oops, excuse me. This will be -2 over 1. The exact opposite would be -2 over 1. See how I just took it and flipped it over and changed the sign? That's what negative reciprocal means. All right, so let's try 13. Determine whether a pair of lines are parallel, perpendicular, or neither. So what we need to do is we need to get each one of these lines into slope-intercept form, because all we need to know is that slope, that m. Once we can examine the slope, we know if they're perpendicular or parallel. So when I look at this first equation, right, I have this 10x plus 5y equals 5. I want to get the y by itself. So I'm going to minus 10x from both sides, giving me a 5y equals -10x plus 5. Now we want to get y by itself, so I'm going to divide by 5, giving me y equals -10 over 5x plus 5 over 5. Now we can simplify this to be -2 and this to be 1, right? So -2x plus 1. My slope here is -2. Now, when I look at this one where I have a -x equals 2y plus 16, once again, I want to get this y by itself, so I'm going to minus 16. Minus 16. So this, I can rewrite this as 2y equals -x minus 16, because technically this would be -x minus 16 equals 2y, and I can take this 2y and just move the equal sign on the other side and write it as I just did. Now all I'm going to do is divide by 2, divide by 2, and divide by 2. These 2's go away, leaving me with my y. This is a 1, so that's a -1/2. Right here is going to be -8. So now let's look at our slopes. Our slopes are -2 and -1/2. Now, if they were going to be parallel, Oops. If they were going to be parallel, they would have to be the same. Are they the same? Negative 2 is not the same as negative a half. So that doesn't work. If they are going to be perpendicular, they have to be the negative, right, reciprocal. Negative reciprocal means that we have opposite signs, first of all. And notice that they're both negative. So since they're not the same and they're not negative reciprocal, the answer is they are neither. Okay, they're not parallel nor perpendicular. Let's go ahead and look at 15. Same deal, negative 8x plus 8y equals 0. We have to get y by itself, so I'm going to add 8x to both sides. 8y equals 8x. Right? See how that's 0, so that just goes away? Now I have to divide by 8. When I divide by 8, that gives me y equals x, because there's a coefficient of 1. So that means there's a 1 here, right? So the slope in this case is just 1. That's what we're looking for. When we look at this one, we have x minus y equals 4. So we have to subtract x from both sides. Now there's an alternate way to do this, but we're just going to keep it simple right now. And now notice I have a negative y. Do I want a negative y? No, I want a positive y. So if I'm just going to go ahead and multiply everything by negative 1, which just means change the signs. Y equals x minus 4. So there is an invisible 1 here, correct? So that makes this slope 1. Are the two slopes the same? They are. So this is a parallel line, right? These lines are parallel to each other. All right, so that wraps up 1.5a. We will go over the even ones in class. All right, if you were absent, you can continue watching on this video when I post the entire thing to see these even ones done. All right, I will see you in class.